them for the poll in the afternoon.
Yeah. So see, we are also having a audience poll. So they will also choose the best team that presented well. So you should all, have a lot of people in the audience. You should fix it up, do some match fixing.
Ma'am, that YouTube is live. You just check.
Listen, Arvind Raj, I'll do that, Robin. Arvind Raj, are you able to unmute?
Yes, ma'am. Yes, ma'am.
So hello, how are you all?
Fine, ma'am.
Prepared well for the competition?
Yes, ma'am.
Yes?
Yes, ma'am.
Confident?
Yes, ma'am.
Good. So you're having people, students and faculty from your college coming?
Ma'am, I'm not sure about that, ma'am. I'll talk with them. I'll ask them, ma'am.
Sure, okay.
Chandrini, are you able to unmute yourself?
Yes, sir.
Okay, fine. Sujata ma'am, she is another MC from Sona.
Okay, hello Chandrini.
Yes, ma'am.
Dr. Suresh is joining. Chandrini.
Yes, sir. He will be joining.
Okay.
Robin Ram has joined. Can you please co-host him? And there is the boss, the Titans, Turbulent. I see many of them not co-hosted.
Hey, good afternoon, Ram.
Turbulent.
Good afternoon, everybody.
Ultimate.
You have to co-host Dr. Ganeshan also. Can you co-host Dr. Ganeshan? He's also joined. Or
yes,
just unmute him. Just unmute him so that I can speak to him for a second.
Done.
Yeah.
Good afternoon, sir.
Good afternoon, all of you.
Welcome to the program, sir.
Yeah.
Sorry, morning I couldn't pick up your call. I was in a meeting.
Yeah. Just I was trying you and Lavana madam. Okay. I told Dr. Silraj sir to join.
Sure, sir.
2:30.
Robin, you'll have to co-host Bharani also. Anu is also there.
Yeah, thank you.
Anu is also there.
Backup. Good afternoon, ma'am.
Good afternoon. Co-host Parati Parvala. I'm going to watch.
Yeah, Robin, me myself, I don't need to be co-host.
Okay, no issues. I have done it.
Yeah, okay. I mean, if there are no issues, now fine.
Thank you, Bernie.
You can all mute. You can all mute actually, not a problem.
Yeah. We'll put it on mute.
அந்த ஹேக்கத்தான் பார்த்துட்டியா? ஓகே சொல்லிட்டேன்னா உனக்கு லிங்க் அனுப்புவான்.
இந்த program start பண்ணி விட்டுட்டு I will just take a look into it. Anu. Just 10 more minutes. I'll start this program and then I'll be. Arun, I don't know if KK is joining. Did you confirm with him?
I spoke to KK. Sorry, I spoke to KK. He said he's not able to make it today.
So it is you and Ram?
Me, Ram, CNC.
Okay, CNC.
And Mr. Jayant Sathe. Mr. Jayant Sathe is still is to join. He probably will join.
Okay, and Robin,
I am
management
2:30.
representative. No, management representatives from both the colleges.
Yes. Dr. Cyril Raj is not joined yet. I'll check with Sona also.
So can I do a quick roll call? Dr. MGR, what is your team name?
Team Titans, ma'am. Team Titans.
Okay, Titans. All four of you are there?
Yes, ma'am.
You're there logged in into the Zoom meeting?
Yes, ma'am. We are there.
Okay. Sona, what is your team name? Sona College of Technology. What is your team name? Okay, moving on. Hindustan. Hindustan Institute of Technology, HITS. Nobody from HITS have joined yet? Robin, Dr. Cyril Raj has joined. Can you?
Welcome, Dr. Cyril Raj. Good afternoon, sir.
Good afternoon, sir. Good afternoon, sir. Sir, Dr. Ganesan, sir?
Yes, yes. Good afternoon, sir. Good afternoon.
Yes, sir. Yes, sir. Yes, sir.
I am available. Our team also has joined.
Okay. So totally how many teams have joined, sir?
No, each university only one team.
Okay, 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 okay.
This
okay.
time they restricted only one team. So
Okay.
last time we had 3 teams.
So how many universities have participated, sir?
Now in this four or five universities.
Six colleges,
Six
Dr.
colleges.
Cyril Raj. We have 6 colleges.
Okay, ma'am.
And
Okay.
each college has one team comprising of 4 students each.
Okay, ma'am. Okay, okay,
So
okay.
we will be conducting this program over the next 5 days with each, each day having 6 to 5 to 6 colleges.
Okay,
each
madam.
day.
Okay, okay, okay. So only these, 6 colleges again and again, they'll be hosting, no?
Each day will be different set of colleges.
Okay, that's what. Okay, okay, okay.
Yes, Mr. Jayant Sathe. Good afternoon, sir. Thanks for joining.
But you're allowed to join anyway. As a As an audience, people are allowed to join Dr. Sharthi. Sanuvya.
Good afternoon, Anuradha madam.
Good afternoon. How are you?
I'm fine. So it is nice to see the real such engineering initiatives
No, we
happening.
should use technology to the best of ability for real life comfort.
Challenges, no, really makes a perfect engineer. Really great. Hats up to you to PALS.
Robin, Mr. Jayant Sathe is joined. Can you make him a co-host?
Yes, yes.
Sujata, you can start. If you're...
Yeah, Robin, I think we should get started.
Yes, yes. Good afternoon. I am Robin from PALS Program Management Office. Welcome to the first campus event, Analyze, a case study based event hosted by Dr. MGR Education Research Institute and Sona College of Technology. I would request the MC of the day, Logeshwaran and Chandrini, to take care of the proceedings. Thank you.
Good afternoon.
Lokesh.
All. Yes, sir. So is my voice audible?
Yeah.
Yeah. Good afternoon to one and all who have joined us virtually for PALS Analyze 2021. I feel privileged to welcome all the dignitaries with great joy and happiness. So let us start with the Zoom code of conduct for the day. Okay. Before going to the event, we need to mention certain ground rules. So all are stay muted. For marking the attendance, please type your attendance in chat box, your name, hyphen college short name, and in the event end, if you want to raise the questions, there is an option called raise your hand. Type the questions in the chat box. Thank you. I would now like to welcome Arun Dev sir, PALS champion, to brief on the event.
Yeah, good afternoon, everyone. Thank you for joining us on this PALS Analyze program. Special welcome to Mr. Cyril Raj and Dr. Ganeshan for their presence here on the start of this event. And also Mr. Jayant Sathe, who's an industry specialist who's been helping us putting together some of these problems on core engineering. Now, coming back to the basic program, one of the key inputs that the PALS governing body has been receiving in interactions with senior management from our partner institutes has been to improve the industry connect, the academia industry connect. Now, there are many ways in which this is done. One is factory visits. Second one is virtual factory visits, given the situation today. A third one would be the faculty development programs conducted by industry, much like the Breaks India program that was conducted just last week. Internships is another method. But to take it forward at a student level on a mass scale, because industry is generally a little diffident to take students into factory visits because of the sheer numbers that they need to handle. PALS has conceived this Analyze program where they try to put in case studies from industry which students would solve and get an exposure as to what actually transpires in industry. Now, if you recollect, in the previous years, we have had Analyze programs where we used to have a host college and then students or teams from some other colleges which will group together there. A problem statement would be shared in the morning, and within an hour or so, the student teams will have to come up with a problem solution. And then they probably had about 3 minutes to describe what they've thought through and what their assessment of the situation is. The pandemic has provided us an opportunity to rethink the way this whole program is conducted. And we have tried to utilize this to make it a little more rigorous in terms of solution, in terms of problems, solutions, as well as the extent of engagement with students. So we have worked closely in this case today's and on the problem statement 3, which will come 2 days later, with Mr. Jayant Sathe, who's been in the industry for over 3.5, 4 decades and is very well conversant with some of the more technical challenges that industry faces. So what we have done is basically conceived of problems which industry faced and solved, and tried to put together a small case study which our students would be able to understand given the knowledge that they have picked up in their curricula, and then try to arrive at a probable solution. Now, in arriving at the solution, it's not only a question of applying the basics that you learn in engineering education, but it's also about considering a host of other factors that impact the final solution that you come up with. There is the environment, there is dust, there is shortages, there's resource constraints. So the whole set of things that you're exposed to in industry, and we try to bring all that into our case studies so that students are forced to work around or work within these constraints and find an optimal solution. There is no one best solution. There are always optimal solutions for different situations, and different teams would have to work on achieving these solutions. Today's program and on all our analyzed programs, we have a team from PALS and our external faculty who has helped us put together these case studies to evaluate each of the team presentations and how they have analyzed it, what is their understanding of the situation, what are the assumptions they have made, the justification for those assumptions, and then the final solution that they have proposed, along with consideration for the constraints that we have put in each of these case studies. So this, in effect, is to give our students a very good exposure of what they need to consider. It's not a question of just applying basic learnings from college into industry. I would expand a little bit more on this when I speak about the specific case study today. So this, in effect, is what we are trying to achieve. And hopefully our student community will also benefit from this. They also realize and get a wider understanding of what it takes. And to make it more interesting, we also have an audience poll at the end of the day today, so that we have a lot of, apart from the teams who are participating, we also have students from the colleges who can vote for the best presentation today. So this, in effect, is our competition. We have restricted it to 5-6 colleges so that they are given ample time, 10 minutes, to express their solution, not rush through in 2 or 3 minutes. They have ample time to make their case, justify their case, and provide their solution. And therefore, we have split our partner institutes in 5 batches, and we'll be doing it over the next 5 days starting today. We hope we will be covering all our partner institutes as a result of this. So this, in effect, is what is the PALS Analyze program for 2021. This is an experiment for us too. We want to see how this works. We also would value your feedback at the end of the session, at the end of each session, so that we understand whether we are heading in the right direction and what other changes we need to do. So with this, I hand it back to our MCs to take it forward. Thank you.
Now I request Chandni to welcome Dr. Cyril Raj from Dr. M.J. Educational Research Institute.
I'm profusely elated to take an opportunity to introduce Dr. Cyril Raj sir on behalf of Dr. MGR University Institute to address the gathering.
Respected officials, of IIT PALS, dear faculty colleagues and students' participation of this analyze program. Long before, I think all the faculty members remember the Bloom's taxonomy was introduced to the teaching community, how we have to plan the content delivery to the students. I think we can recollect the Bloom's taxonomy says that the basic level teaching should be for remembering, and the next level is for understanding, and then the next level is apply, and then the fourth level is analyze, and then the fifth level is evaluate, and then the next level is create. Now, it is the right time that actually we have to do we have to have an analysis of how we deliver the content, what type of content that actually we are delivering to the students. So, if we are sitting in the level 1, that is the remembering level or understanding level, level 2, and then level 3 apply level, so we are not creating good engineers. So definitely we need to focus from the level 4, that analyze and then evaluate and then the create. So really I have to thank the PALS Nuclear for making both faculty as well as students to sit on to the level 4 of the Bloom's taxonomy. So it is only from this particular level onwards. So definitely the innovation will take place. So in the previous level nuclear, so at the maximum it is remembering, and then the copying sort of activities can alone takes place. So that's why actually I said this is the right way of making the students to really to have a deep dive on that particular problem there. So I can quote some examples from our university practices also. After understanding the importance of the Bloom's taxonomy, we identified certain 4 subjects in all the departments, and then every semester we made that particular subjects to be taught in terms of ETL, that is extended embedded theory and then the laboratory. So we named that as ETL. So the ETL kind of subjects nuclear should be taught only by industry experts. So the industry experts along with the faculty coordinators, they have to take that particular, teach the particular problem in terms of the problems like what right now we are discussing, that the providing air conditioning facility with this particular constraints. So when thermodynamics are such subjects are to be handled, so it is we are expecting this way of handling that particular subjects also. So at the end of that particular semester, a student could able to demonstrate, prove that his own design and then his own implementation. So the end semester examination need not be a written examination. So where he has to demonstrate his knowledge on that particular subject by having this sort of analyze. So really, I'm happy to align our university system with the IIT PALS initiative also. And then my earnest request to my dear friends over there in IIT PALS Nuclear, you have experts in all domains as well as in all the subjects. So definitely, if we have
I think he has some internet.
data. Hello, hello.
Yeah.
Am I audible?
Yes, yes.
Now,
yes.
now audible.
Sorry,
Yes, sir.
sorry. I have.
So you can start, sir. Dr. Silraj, you can start. You can continue, sir.
I think he has some audio issue, internet issue.
I'll check with him.
I had a disturbance. So
Yes.
my end is to
Ruben, why is he being muted?
Yeah.
sorry.
Yes,
Hello?
sir.
Yes, sir. Audible, sir. Audible. You can continue.
Sir, sir if you have internet issues, that.
Yes, sir. That is the internet issue.
Okay. Thank you.
Okay. So my request to IIT PALS Nuclear, please prepare a bank of these sort of analyzed problems and then pass it on to us so that Nuclear, as faculty members, we can really take these sort of problems to our students so that Nuclear, let our content delivery can be based on these sort of case studies, because the students can really understand the subjects Nuclear if they do a lot of case studies. So with this, I thank PALS as well as I appreciate all the students who are participating in this analyst program. A grand success.
Thank you, sir.
On behalf of PALS Association, I thank him for providing his gracious presence to. Thank you, sir.
Now I feel privileged to extend my warm welcome to Dr. P. Suresh, Professor and HOD Mechatronics Department and PALS EC member of Sona Institute of Technology, to provide an address for the gathering.
Yeah, good afternoon.
Good afternoon. Thank you, sir.
Hello.
Yeah, we can hear you.
Yeah. Good afternoon to the members of PALS and the other college coordinators, as well as students, as well as the participants for this program, Analyze program. I warm good afternoon to each and every one of you. So on behalf of Sona College of Technology, I extend my congratulations to the PALS coordinators to arrange such a kind of a program to enable the students to enrich their knowledge. Especially, I used to say to the students that normally don't try to become an engineer, right? An engineer is just getting a mark, getting qualified in some of the programs, but it's above and all that normally I used to say for you become a skilled engineer. So maybe this kind of programs, analyze programs, can help the students to enrich their knowledge and become a skilled engineer rather than a regular engineer. So every company is expecting that you are a day one billable engineer. So on that aspect, I think this program will definitely help you to enrich their knowledge, technical knowledge, and they can be competitive in the world. And also, I can say that maybe this kind of, maybe in our curriculum also we as a practice, right? Maybe I'll try to share with the members of the other colleges also. We have involved 3 mini projects which actually help the students to participate in many of the hackathons, and the hackathon events is organized by national level as well as state level events. So definitely these kind of programs will enrich the students' knowledge to become a skilled engineer. Once again, on behalf of Sona College of Technology, I should thank the PALS team for organizing such a kind of event. So definitely I request all the students to make use of this opportunity to become a skilled engineer. All the best. Thank you, sir.
Thank you.
Yeah.
Now I request PALS champions to explain the problem statement for the case study today and the solutions expected and the time limit for each team for the presentation.
Yeah, good afternoon once again. So welcome teams. All of you are well prepared and charging to get on with it. I will just give a brief synopsis of what is the case today. This is a very simple case. None of our cases are going to be any rocket science. It's a simple problem about air conditioning in a confined environment. It's a steel melt shop. I'm sure a lot of you would have now gone and seen or Googled what is a steel melt shop, what happens in a steel melt shop, what is the environment in a steel melt shop. There's a lot of dust, there's a lot of lime and iron oxide and other elements. It's also very, very hot. Steel plants are normally near the mines, so they're also near the mines. The temperature is very dry and hot. So that's the environment in which all the equipment there are expected to function. These are very severe conditions. Standard equipment normally would find it very difficult to function in these atmospheres. There are a number of cranes which is operating here. Each of the cranes today, at least in India, are still manually operated. Sometime in the future, you might want to automate it or pay some developers to be able to handle it. But we still have human manpower that climbs into these cabins and operates these cranes in the steel melt shop. Typically, the temperature in these cabins are between 35 to 50 degrees centigrade. Now, here's your challenge. You are the plant engineer for a steel melt shop, and you have two simple objectives. One objective is to help the production department achieve its throughput. And this you achieve by ensuring that all the equipment that they will use all function and there is 100% availability of all this equipment at any point of time. So that is one of your prime objectives. The other prime objective of a plant engineer is also to lead a team of supervisors and workmen who will help you in the maintenance of all the equipment and ensure their availability as tasked by management and the production department. So when you are managing people, you also have to take care of them. You have to ensure that they work in a safe environment. You have to ensure they're given proper PPE, personal protective equipment at all times. You also have to make their ambient conditions bearable. You cannot expect them to work at 35 to 50 degrees centigrade at the same productive level as what you would expect at normal ambient temperatures. So you will have to provide him with some cooling facility in that cabin where he is working. A standard air conditioner, you have that input, does not work in that environment. It fails repeatedly. And therefore, the chief engineer or the plant manager of the steel melt shop has called you and told, please find a permanent solution to this. We cannot be having this repeated failures and complaints from the crane operators about the extreme heat in that cabin. So that is your problem today. And you also have another constraint, lest you immediately say, I will buy the biggest air conditioner or this or that. There is a cash limit of 75,000, which is the budgeted expense for this replacement and permanent solution. So we now look forward to hearing from the teams as to how they approach their problem, what their analysis of the situation is. There's also a simple question as to why do you think a standard air conditioner fails in that environment? And then how do they arrive at the solution that they are presenting? As mentioned earlier, all the teams will be evaluated by teams from PALS. There will be a winner. The winners will be announced early in March, after all the competitions are over. One winner will get a prize. The one team winning will get a prize. And of course, there's also the audience who can participate and identify one winner in a poll at the end of the day today. So with this, back to the MCs to take it forward, team one onwards. Thank you.
Thank you, sir. Now I request the first team, Mechanizer from Sona College of Technology, to start with the presentation.
So before that, Mr. Arun Dev and Ram, you're ready with the valuation matrix and all that, right?
He is also there. He's also got the matrix.
CNC and Jayan Sate also, yeah.
Yeah. You're good. You're good.
Yeah,
Thanks for checking.
yeah, fine.
Thank you. So Sona team, are you ready?
Yeah, one request to the teams, please keep your presentations to 10 minutes. You will be given only that much time to explain to your boss what is your solution. Anything more than that, he will say, move on with it. I don't have time.
Hello, excuse me, sir. We are having a technical problem, sir. We will do it within 5 minutes, sir.
Okay.
We can call the other team otherwise.
Thank you, sir.
Yeah, Logeshwaran, can you move on to the next team?
Now I request the next team, Team The Boss from KSR Institute for Engineering and Technology to present their presentation.
Yeah. Good afternoon to one and all. Am I audible to all?
Yes, yes, Vinod Kumar.
Yeah.
But there is a lot of background noise at your end.
Yes, ma'am.
KSR IET, can you get started? We are not going
Yes,
to waste time. Yeah.
One second.
See, I request all of you to, keep your presentation ready. Logeshwaran, which is the next team after KSR IET?
Ma'am, after KSR IET, it is KS Rangasamy College of Technology.
So KSR CT team, can you please keep your presentation ready?
Sure, ma'am.
Thank you.
We will be ready, ma'am.
Yeah.
Go ahead.
Yeah, can I start my presentation?
Yes, go ahead. KSR
Yeah.
IET.
Good afternoon to one and all. I am myself Vinod from KSR IET from the team boss. Today we are going to propose a solution for the problem. The bursting air conditioner in a hot metal handling crane. Yeah, the list of the contents we are going to present is first thing is why the air conditioner is failed on that particular environment. Then propose the system which is solution for that particular problem. Then methodology which we are going to implement on that environment. Then cost estimation for this whole project. Yeah. First thing, why air conditioner fails on that hot environment in the sense the biggest trouble dust can cause the reducing level of the heat exchange in both an indoor and an outdoor heat exchange coils, which in the sense which will prevent the coil from absorbing or releasing the heat. As we all know the principle of air conditioner, which will based on the heat exchange methodology. The dust from the environment will sediment on that particular area of that both of the copper coil or heat exchanging coil. It will prevent the releasing or absorbing of the heat on that environment. It will also drop the heat, drop the cooling level on the indoor environment, which will make harder to the AC, which is an air conditioner, to harder to compensate. Which is go in the end at the speed up the air conditioner, which will end in wear and tear expenses. The dusty environment coil can also begin and to develop an ice inside the cooling coil, which may cause severe conditions like bursting out the cooling tubes and so on. This is a identified problem why the air conditioners fail in that intended environment. The proposed system is, as we know, the Peltier principle, Peltier effect, and Seebeck effect, Thomson effect, which are based on thermoelectric principles. We proposing an Peltier effect based air cooler or air conditioner, which will act as a cooler or also a heater, which is working based on the thermoelectric principle. The thermoelectric heat pump is the proposed thermoelectric heat pump is a solid state active heat pump, which will transfer the heat from one side to another side. which will depends on the heat transfer will depends upon the consumption of electrical energy and also the direction of the current. This module or the system is not a polarity based, so the polarity, if we change the polarity of we change the polarity for the module, the heat exchange will be in opposite direction. It can be also used as temperature controller that either heats or cools. The technical specification of an air conditioner which we are going to design is an 90 cross 120 centimeter as an indoor unit and 120 cross 150 centimeter in an outdoor unit. The material used is a general thermoelectric module like Peltier modules, and also an aluminum as a proposed heat sink. Then the power supply which are going to fed into the devices and DC direct current based 24 volt and 10 amps based power supply. Yeah, the technical specification for the filter which will prevent the dust sedimation on the outdoor unit. The outdoor unit consists of various heat sinks, consist of high efficiency MERV filters, which are very high filtration rate compared to the market available filters. It must be replaced for every 6 to 12 months, and so on. Yeah, the methodology which we are proposing is an Peltier coefficient based air conditioner. The black bordered line is considered as a Peltier device. At the top of the module is considered as a cool area. Then bottom of the module is considered as a hot area. When we supply an recommended power supply to that Peltier module, it will start to generate a heat on the one side, and also at the same time it will also generate a cooling effect on the other side. It is based on the thermocouple principle. It is also a semiconductor device, so it will work on the as a p-n junction, like kind of electron jumps between those p-n junction diode. As we know, and as in the sense, Peltier device will act as a heater and cooler, as I said earlier. If we try to reduce the hot surface of this Peltier module, the cooling effect of the Peltier module on the other side will be increased. So in the hotter side of the Peltier device, we are going to implement such kind of aluminum heat sinks to compensate those heat on the opposite side. The environmental neutral air will be passed through the hot side of the Peltier device. It will reduce the actual heat of the Peltier device. Then it will, on the opposite side of the Peltier device, the cooling effect will be increased. So we can pass the neutral air through the fins of the cooling side. It will help to cool the intended environment. This is what the proposed system. Yeah, the another thing is we are going to implement an array of Peltier modules in an intended environment, which is consist of both the hot side and cool side. The cold side will be on the inside of the environment, which is an inside of cabinet. The outside of the cabinet, which is an outdoor unit, which is an hot side. The hot side will be cooled to increase an efficiency by using an aluminum fins. Yeah, the cost estimation for this proposed idea is a microcontroller which will automatically blow air between the hot and cold side. Then the Peltier device of the 20 quantity. Then power supply for this entire system. Then filter unit for the external in the sense outdoor unit. The heat sink, which depends upon the environment. As it increases the heat sink quantity, the efficiency is also going to be increased. Then the coolant liquid for if they need it, in the sense if as we studied in the problem.
Team, you have crossed the 7th minute.
Yeah, okay, sir. As we studied in the problem statement, the intended environment is in a high temperature area. So if we need an external cooling for the external unit, in the sense we can add a coolant liquid, then copper tubes for the coolant liquid.
Reminder, one sec.
Yeah, thank you.
Thank you.
Thank you, team. Now the team is open for questions.
Thank you, the boss team from KSRIET.
Thank you.
a good explanation of how you will have gone about the solution. Let us hear from the next team. Who's the next team?
Now I request team Ultimate Innovators from K.S. Rangasamy College of Technology to share the presentation.
And Logeshwaran announce which is the next team to follow.
The next team is team from Dr. MG Educational Research Institute.
Okay. KSRCT, are you ready?
Hello, sir.
Go ahead.
Sir, we are from KSR City, and my friend is stuck in some net. Like, please make them as co-hosts, sir. KSR City, Dhanush.
Yes.
Robin, there are a couple of more students, I think, teams which you have to make.
Yeah, I have made it, but again they have logged out and logged in.
Yeah, so just be aware. Yeah,
Yeah,
go
yeah.
ahead,
Hello.
KSRCT. Yeah.
Yeah, hi, ma'am. Is I'm audible?
Yeah, go ahead.
Yeah, sure. Yeah, hi. Myself Dhanush from College KS Rangasamy College of Technology. We are going to give our solution for the given problem statement. Like the normal, first of all, the problem is like the AC is getting unworked due to the inner climatic or the situation inside the industry, because there is high temperature inside the industry, like it's 50 degree above 50 degrees Celsius. But so that we can give a easy solution, like we can place the AC outside the industry on the top of on the top of the industry or outside the industry. From that we can take a pipeline that we can directly give it, like the pipe should be like, it should be a vacuum pipe, and it is of a vacuum technique, like there will be inner pipe and outer pipe, and the between there will be vacuum, so heat won't there is no heat conduct through the pipe. And to cover the pipe we can use fiberglass fiber. The exact name of the thing is, one second, and the exact name of the thing, fiberglass insulated sleeves. We can use those sleeves to cover the to wrap the pipes that comes from outside, and this pipe can be let inside to the cabin. So like the cabin also can be done as a vacuum cabin, like there will be like as similar to our as airplanes cabins are made, the glasses in airplanes, there will be a one glass and there will be two glasses, and in between there will be a vacuum. Since glass is a glass is a bit has higher resistance to heat, it does not allow that much of heat to transmit to the glass, and even though it's vacuum, so there will be no problem with the heat transmission. So the pipe can be directly given into the cabin, and this can make there is no like we need to only invest on the only the pipe material and the cabin, so there is no need to change any specification of the AC that we use. This is the solution from our end. Hello.
So you're saying the current AC should work if you take all these precautions. So that's what you're saying.
Yeah, sir. Like if we take this AC out, like The main problem we are facing is it's getting damaged due to the temperature that's inside. If we take the AC to the normal temperature, outside the temperature, like outside temperature, it will be maximum about 34 or 35 maximum. That I think the place where it is, and like AC can convert 35 into 26 or 17, but it can't, like it can convert 50 and 60 degree to like 26, but it lifetime decreases as it converts. So by this way we can increase the lifetime also, and there is no need to invest so much of money, etc for new model of ACs and all.
Yeah, how long will that pipe be? You're talking of a vacuum technique pipeline.
Yeah, yes sir.
How
So
long?
like, yes sir, like this pipe we can go like a fiber, as I said, fiberglass sleeve that can be wrapped outside, so that it is a like a good resistor. It can resist up to 150 degrees Celsius. So I think inside the industry there won't be 150 degrees Celsius. Like, may I know the like what is the maximum temperature that is inside the industry?
That is 50, no?
Yeah,
See,
okay.
this is some of the things that we want you to investigate yourself.
Yeah, like we have investigated it and we have came with the idea. So if this idea is suitable, we can process this idea and we can analyze what and all can be made, what and all materials can be used. So we have came with the idea.
Okay, very good. Thank you very much.
Yeah, thank you, sir.
Next week. Hey, MCs, are you there?
Yeah, the next team.
Call the next team, please.
The next team from Dr. MJ Education and Research Institute is now presenting, sir. Is the screen visible?
Yes, yes, go ahead.
Yes, sir. We are the team Titans from Dr. MJ Education and Research Institute who have solved this problem, and we have come up with a solution based on the analysis that we have performed, sir. So these are some of the assumptions that we made. So we have assumed that there is an efficient compressor which is suitable with suitable refrigerant that is able to work with of a temperature of about 108 degrees Celsius, above which the compressor leads to a worn out or it damages. So the next step that we have assumed is the refrigerant is within critical temperature of about 152 degrees Celsius, ensuring the higher heat transfer gradient. So the third assumption that we have made is we have based on the ambient temperature. So we found the temperature gradient about 50 to 58 degrees Celsius, sir. So the first question, explain why do the standard domestic ACs fail in this environment? So there is one main reason. There is one main reason for the domestic ACs to fail. The dust particles, especially the lime and iron oxide, make a layer of coating on the condenser fins and tubes, which traps the heat within the tube. So, sir, there is some disturbance actually.
So others, please
unmute, please.
Mute. We have to mute everybody.
The dust particles, especially the lime and the iron oxide, this makes a layer of coating that is harder than the cement as given in the problem statement on the condenser fins and the tubes. This traps the heat within the tubes, which creates a problem in the heat transfer. So what are all the conditions that this layer of coating increases? So under ideal condition, what happens is the rate of deposition of these lime and iron oxide increases since the cooling fan is not operated. Under ideal conditions where the AC is turned off, so this gives the increased chances of increased chances of deposition of lime and iron oxides. So the deposition also takes place through the other vents in the air conditioner. So this is the third inference that we have made. So what are the technical specification that we would include in the air conditioner we design? So we would design an air conditioner with a refrigerant R600A, which has a critical temperature of about 152 degrees Celsius to maximize the heat transfer. The condenser is fitted with the metal mesh on both the sides with the electrostatic precipitation concept and with anti-deposition coating, where most of these iron oxide and lime particles are trapped. no way heat is trapped here, because there is they have enough porosity for the air to travel in and out. And the one more thing is this metal mesh also has the capability of making a heat transfer through convection way, so there is no problem of heat trapping. So the third point is the indoor unit, which is enabled with the ultrafiltration porous material for trapping these particles within the cabin. So in the indoor unit, it is not possible to make an electrostatic precipitation concept, but instead we can go with ultrafiltration porous materials which are fitted over the air that is sucked inside during the process of cooling. So the cabinet is ensured with maximum sealing to prevent the transfer of these particles from the surrounding to the cabin. So what is the heat transfer area? Estimated size of the air conditioner, dimensions and weight. The heat transfer area, the heat transfer takes place at the condenser part of the air conditioner. So based on the fins that is present in the air conditioner's condenser, so we have come up with an total heat transfer area of 14,400 centimeters square of fins, and dimensions in centimeter is as same as an existing external unit that accounts up to 67 into 71 into 46 centimeter. So the weight of the air conditioner also lies up to 56.01 kg, where it comes with the weight of the compressor, condenser, the mesh filter, and the external casing. So what is the maintenance that we would afford? So the low efficient acid, the acid that does not react with metal. So we have decided with acetic acid soaking and spraying for removal of lime and iron oxide deposition in the filter mesh and tubes. So this is an usual way used for removal of this limescale deposition, and this is done in repeated manner. So coating of anti-deposition anti-deposition coating is also made on the surface of the fins, so that helps cleaning of these metal mesh and as well as the cooling fins. Thank you so much for the time. Thank you.
Thank you, Titans, for your suggestion as to what should be the solution. You're looking at a split air conditioner, is it?
Yes, sir.
And ultrafiltration equipment around the cabin as well as around the unit.
Sir, not around the cabin, sir. The ultrafiltration material is placed inside the indoor unit, and for the external unit, and metal mesh made of and metal mesh with charged particles is placed before and after the condenser, sir. So this actually attracts the lime and iron oxide particles that enters during the heat radiation by the cooling fan, sir.
If you had seen any of these videos on the steel melt shop, and I think we have mentioned it in the case also, on
yes,
the same rails, I have got a number of cranes moving.
Yes, sir.
Each of them will move independent of each other. They need to work on their own loads and other things.
Yes, sir.
So when you have a split unit like this,
sir, sir, anyway the condenser unit has to be placed away from the internal cabin. The condenser unit cannot be placed inside the unit because it acts as a refrigerator that we use in our home. So there is no chance of heat transfer taking place within the room itself. So anyway, it has to be placed outside, so that it is not that it has to be split, sir. It can be used in the combined way also, where the entire unit is placed outside, and with the help of the duct, the airflow is maintained.
So in other words, it's attached to the crane only. It's not outside the shop.
It's not outside the shop, sir.
Okay.
Mr. Sathe, any questions, sir?
No, I have understood. I will give my comments at the last.
Okay. Thank you. Thank you very much, Titans, for
Thank
your
you, sir.
thing. We go on to the next team.
Lokesh, can you call the next team?
We now request Team Turbulent from Loyola ICAM College of Engineering and Technology to share their presentation.
1 minute, sir. So can you able to see the screen?
Yes, yes.
Okay.
Put it in a slideshow.
So good afternoon, everyone. So we are Team Terminites from Lizard. So we have found some solution for the problem. So let's start the presentation. So this is the problem statement given. So as per the condition, the environment is very hot and it consists of dust with lime and iron oxide. So there is a lime and iron oxide in the dust, and the given ambient conditions are higher. Normal. The given ambient conditions are 35 to 50 degrees Celsius, which are higher compared to the normal working conditions of the standard AC. According to the problem, the cabin operator requires an comfort level about medium to high. So these are the arrangement is like movable. So the condenser and the have to be placed on the crane itself. So according to the case study, the failure of the normal standard AC are classified as two. One is due to the outside ambient temperature. Since the ambient temperature is higher, the heat transfer efficiency of the coil decreases. Thus, the load on increasing the pressure of the condenser coil lies on the compressor. The load on the compressor increases, which leads to the failure in a very short period. Second one is due to the dust environment. Since the environment consists of lime and iron oxide, it used to sediment on the condenser coils, which drastically reduce the heat transfer efficiency of the coil. So these are the two conditions which majorly causes the standard domestic AC to fail. So our design is basically like to prevent the to improve the heat transfer efficiency of the condenser coil and to prevent the sedimentation of the dust and the lime oxide. So lime oxide and iron can cause corrosion and scaling on the coils. So first problem of heat transfer, we thought of using a water cooled condenser such that we can improve the heat transfer efficiency of the condenser coils. Since it is a closed environment, we can prevent the coils from sedimentations of the dust particles. And second solution is like using of coastal coatings on the coils, which are the epoxy coatings given on the coils to prevent the oxidation reactions due to lime or iron oxide on the coils. So why water-cooled condensers? So water-cooled condensers can transfer heat 15 times more compared to the air. Since the ambient condition of the given problem is higher, we thought of using water to transfer the heat would be a better idea. Since water systems are usually small compared to the air-cooled systems, we thought of using a water-cooled condenser. So the use of coastal coatings. Coastal coatings are, as said earlier, can be used to prevent the deposition of the lime and iron oxide, formation of the scaling and corrosion on the coils. So maintenance required. Since we are not modifying, we are just enhancing the performance of the existing system. The cleaning procedures and maintenance are similar, but since we use a water-cooled condenser in place of an air-cooled one, we need some of the specific maintenance requirements for the water-cooled condenser. Like we need a chemical cleaning procedures due to the circulating water causes some scaling issues inside the condenser coils. That's one of the extra maintenance we have to put in case of water cooled condenser. Apart from that, the design conditions, weight, and the sizes are similar to the existing conditions. So installing this system won't be a problem in the crane. So cost estimation is like the regular air conditioner would cost like 35,000. Fitting an external water cooled condenser would cost about 25,000, and closed circuit cooling for the circulating water would cost about 10,000 totally. So it would cost around 70,000, which is below the given budget conditions. So thank you, sir.
So this water condenser coil, you will have a water connection to the unit at the cabin, is it?
What, sir? Can you please come again, sir?
The water condenser, water cooled condenser.
Yes, sir.
So you'll spray water outside, is it? Or you'll have water?
No, sir. No, sir. We'll use like a shell and tube or a single pass condenser, sir. So it will be like a closed capsule where there will be a counterflow of water on the condensing refrigerant. So
why do you want to do this? I mean, what is the objective?
Mainly the outside temperatures. So since the temperature is higher, there will be a higher pressure increase on the condenser coils. So we want to reduce the pressure. Thus, by reducing the pressure on the condenser coil, we thought of reducing the load on the compressor such that its life would increase. So we thought of using a water in place of air, which would alternatively prevent the coils from exposure to the environment too. We thought of that way.
So the air will be inside the copper tubes and you'll have water around it.
The coils from the condenser will go inside a shell where water will be circulating on the coils, sir.
Okay, right. Thank you very much.
Thank you, sir.
Thank you, Leslie.
Thank you, team. Now I request College of Technology to be ready for the next presentation, and I now request Hindustan Institute of Technology and Science to present their presentation. Now I request Hindustan Institute of Technology and Science to share their presentation.
Hello, can you hear me?
Yes, sir. Go ahead.
Yes.
Put it in a slideshow mode.
Yes, sir.
No one is talking?
Sir,
Hello. Hello, sir.
Yeah, go ahead.
Sir, can you able to hear me?
Yes, go ahead.
Put it in show mode, please. It's very small.
Just a minute, sir. Oh.
Team Hindustan, are you having any technical issue?
Yes, ma'am. Give us 1 minute. It is not able.
Balaji, Mukesh, Vignesh. Where is
Yes,
Balaji?
He is there, ma'am.
I don't see others in the team are speaking at all.
Ma'am, it's me, Vignesh.
Ma'am, this is Mukesh, ma'am.
Okay, so can you all get started?
I will project it for you. I have your presentation.
Is that the problem? I don't think that's the problem.
Sir, is it visible, sir, now?
Vignesh and Mukesh, the screens are visible. I think you can just get started.
Okay, ma'am.
Okay, ma'am. Okay, ma'am.
This is we are from Hindustan, and I'm Vignesh. We're going to give a case study on air conditioning system for hot metal handling cranes. So in this we have analyzed about the issues on air conditioning, particularly on the hot metal handling. And we have made a separate designs like cranes, which could have a better air conditioning system. Next slide, please. Mukesh, could you please change the slide?
Yeah.
You're not on slideshow mode.
Yeah. Come. Vignesh? Hello.
You have
Yes.
any issues regarding the slide?
Yes, sir. I think the Mukesh
Yeah, now I
network
will
is not.
project it now, you see.
Yes, sir.
No problem, sir.
Now I have projected it. Just go through it.
No, Robin, I need it in show mode, Robin. I can't read this.
Yeah, it is in slideshow mode only.
No, I can't see yours. I'm still seeing what they're showing.
They have to stop share, I think.
Please proceed to the next slide.
Okay.
Now it's in slideshow mode. Okay.
Right, go ahead.
Yes, sir. So we are seeing what's the problem statement on the case study. So we need to find the how to process the lime and iron oxide that is coming from the furnace. So the temperature where in that place is 35 to 50 degrees. So it is a quite high temperature for a normal domestic air conditioning. So in particularly we have changed the specification of an air conditioner so that could last more than 30 days. And we have introduced a cyclone separator, which is in-coated with activated charcoal. So this could help us in recovering the dust and lime oxide. So and also it prevents the collects the dust which is around the metal handling area. So this overall issue can be solved with the help of cyclone separator. And from here, Mukesh will continue.
Next slide, please. Yep. Based on the points which Vignesh have discussed before, and we have worked on the air conditioning unit and their standards, where we have used the R237A refrigerant instead of the regular one, which is used for domestic purpose, R121. Instead of that, we have applied the R237A, which in which the critical temperature is quite high compared to the R121A. And then and for filtering the dust particles like for filtering the dust particles, we have used the cyclone separator, which was actually suggested by Vignesh, which reduces the maintenance cost as well as the maintenance work of reducing the or removing the dust particles. And then the total cooling load capacity is around 1 ton. It is actually, and then next slide, please. And these are the standards which we have followed. Then next slide, please. And these are the operating conditions which have been followed by the foundry industries, which is these molten metal materials are handled under extremely high or fluctuating ambient temperatures, where it places very high demands on various components which is used in this processes. Next, please. Next slide, please.
Moved it to the next slide. team.
So I think he's having some issues. Can I continue with this?
Yes.
So from here we could see the findings where we have deliberately seen the die casting. Particularly, we are using a cyclic variation of the temperature. So this could help us in diverting the temperature that is produced from the furnace. And in research and limitations, we could see for economical production and aluminum and alloys have been used wide range in most of the plants. So instead, we could add some other alloys to that, which could reduce the temperature of the alloy, and particularly which practical implications can also be increased in the value. Next slide. Sir. So here we could see the graphical representation of the crane. So these are the 3D structure that we could see, that yellow crane painted. So the graph that's shown in the below are the change in the temperature when we use the crane, which is inbuilt air conditioning. So inside the air conditioning, we have an operator to sit, and the additional functioning of the computer systems and crane control. So, and in outside of the crane, we have an additional filter system that reduces the noise and the temperature air conditioning inside. And we have a small prototype of cyclone separator, which also filtrates the dust and dust of lime and iron oxide, which allows the operator to have a fresh air inside the crane system. Can we move to the next slide? Okay. So this is for the drafting image, and we are seeing the crane how they operate and the hook system we having in the crane below. So this is the particular model type that we have used is the horizontal crane. So this is another overall view that could reduce the temperature in the furnace area. Next slide, please. And this is the side view of the representation. So we could see the crane, it is hanging over at the top of the ceiling, and the operator can operate from there. We have a hook below hanging the crane, which need not to be any worker to stand near the furnace or in a dusty area. So this could prevent from them from high temperature. Next slide, please. And these are the European standards and norms that we have followed. And for specific requirements for crane operating cabins with the high, we have used 1 meter, and it shall be handholds also. Another control station and crane with operating doors will have above 1 meter. So this particularly helps us in making high efficient, cost efficient, and increase the cooling capacity of the AC for prolonged time. Next slide, please. And these are the case study that we have done. So particularly this makes an environment impact, which the steel industry can generate effluent loads, and obviously which helps the production plant to increase more production and reduce the cost that which the plant requires. Next slide, please. And here comes the cyclone separator. Basically, a cyclone separator is a vertical, and it's at the bottom at the conical shape, where the dust is pulled out from the where the area is operated, and due to the centrifugal force, heavy particles which are more than 100 micron sizes are fed down to the conical area, and it is collected in a dust bag or any other in a chamber that collects the dust particles. Later, it can be added some sprinkled water or any other substance could reduce the pollution from the hot place. And they have used various ESP capable controlling particles to reduce the 1000 mg meter per rate, and they have various system while compared to the other operations like electrostatic. While compared to electrostatic and a cyclone separator, we have a highest efficient for the cyclone separator. Instead, for electrostatic precipitator, it is a more complicated, and it It requires more amount of
You
energy
have
and
one more limit left.
yes, I'll complete it. That is why we use cyclone separator. Next slide, please. And this is the 2D structure of the crane and the cabin. Next slide, please. And these are the calculation that we have made for the crane design. And in step 1, we have measured the what should be the volume of the crane, and then we made an requirement for the heat that should be removed from it, and what heat transfer area should be required was for it should be like 4791 BTU, and in 110 AC we could efficiently use this particular thing for the heat removal. Next slide. Thank you, sir.
Thank you. You have just brought in some case study that you've done for industry into this.
Yes,
I don't see any correlation with the case study that we presented to you. Right?
Yes.
We talked about a steel mill. We talked about different things here. I don't see any reflection. There is what you saw is an aluminum foundry and the crane for handling hot aluminum, probably, right?
Yes.
So why is that? Anyway, we keep it at that. Thank you for the presentation. Can we go to the next one?
Now I request Team Mechanizer from Sona College of Technology to share the presentation. Team Mechanizer.
Yes, sir. 1 minute, sir.
Team Mechanizer, if your presentation is available, sir, you can ask sir to share the screen.
Okay, go ahead. We can see it. Good.
Good afternoon, everyone. We are from Sona College of Technology, Salem. This is our problem statement, and we have found some solution for this problem statement in this case study. So we first talk about an introduction of air conditioning. Air conditioning is the process of heat removing from the confined space, thus the cooling of the air and removing humidity. Air conditioning can be used in the both domestic and the commercial environments. This process is to achieve a more comfortable interior environment. We are already aware of a normal working of AC. So in the steel melting shop, excess of heat and dusty air is liberated because of melting metal. That metal is handled by a crane to displace one molten metal to another place. So due to this, some reason in normal air conditioning are not applicable to melting and molten metal handling in a crane. We will see the causes of burning of a normal AC. My teammates explain the causes of failures of domestic AC and its solution.
The causes for the domestic AC failure: the dusty hot air from the metal melting shop consists of lime and iron oxide. These constituents react to form hardened substance like cement. These constituents cannot be filtered by using normal AC filter. So these particles block the filter as well as the hardened substance in the orifice tube of the evaporator. So the domestic AC burned out before 30 days as per the problem statement. The basic components of the AC: compressor, condenser, expansion valve, and the evaporator. We all know that. And the working of domestic air conditioners. We know that warm vapor from evaporator sends towards compressor. Where the vapor pressure of the vapor increases and the temperature also increases. When the vapor goes inside the compressor, then it transfers to condenser. It reduces some heat from the vapor and convert it to liquid. Then it moves to expansion valve.
There the pressure reduces and temperature of the fluid also reduces. Then again it's sent to evaporator and cool air is delivered with the help of a blower. Thus the working cycle happens.
Yeah, as we have explained before, the lime and iron oxide particles form hardened substance, the respective place where the substance blocks the entry of warm vapor from the room. This is shown in figure. This figure consists of the filter, AC filter can blocked by these particles, as well as the evaporator tube, it also blocked this entry. So we have some idea to change this model. We are going to replace the filter as well as the orifice tube in the evaporator.
Yes, sir. Our design planning for our crane operator cabins by placing the filters in the AC can filter the minute particles in the dusty air. So we are using high efficiency HEPA filter consists of 4 layers. The first layer of our filter is pre-filter, and then next is carbon filter. In between these two filter layers itself, we can filter the maximum dust particles. Then we are using the formaldehyde filter, and finally we are using the HEPA air filter. By using these 4 layers in this filter, we can easily prevent the blockage in orifice tube of the evaporator.
In domestic air conditioner, normally evaporator consists of single tube orifice. Now we replace multi-tube orifice with paraffin wax in between the tube, where we use paraffin wax, which reduce the amount of heat in the evaporator itself. The cost of AC we designed is more than the normal domestic AC, because we adding multi-layer filter, and also we replace multi-tube orifice with paraffin wax at evaporator coil. Its maintenance is as like the normal domestic AC.
Yes, sir. If we have some more time, we can design it by software and submit a complete analysis of our solution, sir, with accurate dimensions. Thank you.
Okay, thank you.
Thank you, team mechanizers. Now, I request PALS faculty for the explanation on the problem statement and the additional inputs which we have provided, and the final solution which was implemented already.
So Jayant Sathe, you would like to step in, sir?
Yes, my name is Jayant Sathe. You can see my face also if you wish to. Okay. The first thing I would like to say is take a little bit more time to actually study what is the problem. The problem is not dust as it is. The problem is the lime in the dust. Many of you would have gone to temples built, say, 1,000 years ago or something like that, and you would have noticed that the stones are put together using lime. This lime, which hardens over time, it becomes extremely hard, and sometimes it's even better than our modern concrete. So the problem was that you have moisture in the air, you have lime, you have iron oxide and all kinds of other dusts. Most of this dust is micron and submicron size. Please understand this. So it's very difficult, even if you have, and most of this dust used to settle on the condenser. The condenser in a standard domestic AC, it's a tube with aluminum fins. The aluminum fins are very, very closely spaced. So if the dust settles over there, you can't blow it away because it hardens. You can't use acid because it will damage the film, the aluminum fins. You can't take it out and take it away somewhere else because the crane is working 24 hours a day, which means that it has to work under normal conditions and not stop. There's not too much of a problem if the AC works on the inside. It is only the condenser which is the problem. Now, I also put a figure of 75,000. Why did I put a figure of 75,000? Because it's possible to buy in the market ACs for this application, which costs 7 to 8 lakhs. So the problem or the question was really to use your ingenuity to see what can be done. And the solution turned out to be simply increase the size of the condenser. You use all standard components for everything else. Increase the size of the condenser. You can use aluminum fins. You can use even galvanized steel fins. You place the fins maybe 1 millimeter to 2 millimeter apart. And we added an additional, let us say, twist in the sense that the fan which used to blow air over this condenser, it was reversing for 30 seconds every 5 minutes. In other words, it was blowing out any dust which was being sucked in from the fan side. And this is all. Cost at that time in 2012, it was about 50,000. The AC was built out of standard components in Salem itself. We used a 3-phase motor for the main compressor so that we could run 24 hours a day without any issue at all. There's no need to go chasing for any kind of ESP, no need to look at cyclones which won't work with submicron dust. The only party which really thought out of the box, I will say, is KSRIET. They used Peltier cooler. The only problem is that I don't know whether it will be efficient enough. Your module is 24 volts, 10 amps. Is the power sufficient? Is the efficiency good enough? Because under normal conditions, you will require nearly 1.2 kilowatt to run this AC. For KSRCT, they wanted to take the AC outside the building. You can't take it outside the building. The crane is running on rails. Yes, you can use water cooling, but then what you need is a drag chain to take the water in, the cooling water in, and the hot water out. Because ultimately, if you want to recirculate the water also has to be cooled. And the normal method for using this is cooling tower. You can't have the cooling tower on the crane itself because of the extreme amount of dust. With no time, the cooling tower itself will be choked. The Dr. MGR Institute, they didn't understand how lime hardens. So this is an important thing. You have to understand materials which normally you don't deal with. This sort of thing happens in practice. The filtration, normal filtration, HEPA filter or something like that, it's not going to work because you'll have to change it every day. Okay, acid cleaning, not possible. You will damage the fins. And when are you going to do it? If I'm not wrong, Loyola mentioned the water-cooled condenser, and I have mentioned that you need a drag chain with water pipes and a pump to take the water in and out. This becomes expensive, may not be practical. Sona College were talking of a filter, but only for the inside. They forgot that the main problem is actually outside. And Hindustan have talked about the cyclone separator. It doesn't work. Ultimately, the simplest solution was increase the size of the condenser and allow the dust to float away and not to settle. Physically, a man used to come and clean the condenser once a month, and that was enough. The AC used to run continuously for 29 days. The 30th day, the shop used to shut down for maintenance, and you could shut it down at then. This is about all. I hope it's been some kind of a eye-opener that you need to first understand the problem. If you understand the problem, solutions are easy. When you go out into the field, what you are actually going to have are a series of open book exams. You can collect information from anywhere, but ultimately you have to have a solution that works, and that very important, that you can afford. That's about all that I have to say. Thank you.
Thank you, sir. Thank you for explaining how we actually solved the problem. I think Sona College had a distinct advantage because Salem Steel was right next door. I hope the teams got an exposure of what it takes to solve problems in industry, how to look at problems from different angles, not get too hooked on to some fixed ideas that we have about cooling, cleaning, filtration, etc. You need to look at the total solution in that context, and also the economies of implementing a solution. All this HEPA filter and cyclone, all of them will also need to be cleaned at some point of time. So how are you going to achieve availability of the equipment for the production department as they go forward? So these are some of the considerations, other considerations beyond engineering that we would like our teams to consider when they are looking at solutions. So to that extent, I think we would have been happy to see some of those other factors also being mentioned. I hope all our teams got an overview of how to look at problems today in a core engineering situation. If the teams have any questions and answers, questions, they'll be free to raise it, and we would have Mr. Sathe explain what it is. Else?
Sir, I have a question, sir.
Yeah, go ahead.
Sir, when I mentioned the heat transferred area, I mentioned the total heat transfer is based on the fins. So I said there is an increased heat transfer that we have changed due to the fins that we have set in the condenser part, sir. And the one more question that I faced was when I was presenting was, if the air conditioner is going to be fit on the crane itself. So what I want to explain is a duct where by indoor and outdoor part, I meant to mention the place where the condenser is placed and the cold air is being sent to the cranes, sir. So that is what I wanted to clear out. But the question is, sir, I mentioned regarding the fins, but the fins also get deposited with this lime thing. So instead of the fins getting affected, so what I said was the filter that is going to purify the based on the metal mesh that is going to purify. So we can clean the metal mesh 30 days once, so that this doesn't affect the process of heat transfer. And it is very hard to clean the fin surface since it is complexly arranged. So I face that as also a problem, sir. So that is what how will it go fine? So that was the question.
I will try to explain. Yeah, you are correct in saying that if you prevent the dust getting onto the condenser, you are safe. Now, how successful will you be in preventing the dust from getting onto the condenser? You are saying that I will put a filter outside. Now that filter has to stop this micron and submicron dust. If it fails to stop, it will get onto the condenser, and instead of 30 days, 45 days, later you will have the same issue. So really the thing is that you allow it to settle, but don't allow it to remain there for a long time. What we did was we reversed the fan, and we could get opportunity to actually touch the condenser only once in a month. So as long as you have a sufficiently large filter to prevent dust from getting onto the condenser, that's fine. My point is, how big is it? Because you need to run 29 days continuously. Okay. The other thing I want to say is, you should never assume that there is only one solution. I mentioned the solution that worked and we forgot about it. Your solution was also possible to work. Only thing is, I think the area that you will require, it's the room size. You will have to have filters, such a large filter, in order to provide the air to come in and leave, because if air doesn't flow over the condenser, it won't work. So on the back side of the fan, you need a filter which is strong enough, good enough, and also does not prevent the air from flowing. Okay. Remember also the point I made about submicron and micron size dust. Most of the stationary filters will not stop it. Thank you.
Thank you, sir.
Arundev sir, shall we launch the poll before?
Yeah, I mean, I wonder whether we have any audience at all. Anyway.
Yes, I will launch the poll. The participants, those who have made a co-host, not attempt this poll. And the audience, please attend the poll. I will launch the poll now.
Okay, just for the sake of benefit of the audience, this poll is best is a opinion from you. You have heard through all the presentation. I'm sure once the case study was explained by Mr. Arundev, thoughts would have been running in your mind on what could be the solution. There should have been an intervention to ask your opinion too before we actually gave up the solution. Probably, we'll work it out as a feedback and, do that in the next analyze onwards. Take the audience suggestion as well, audience thoughts as well before we give the actual solution. So we would want you, based on what you have heard today, which do you think was the closest team that came closest to the solution, and also with respect to presentation, we would want you to rate the teams. So Robin's request was those who participated, kindly do not take up the poll. It's not necessary for you. And also those who are the co-host, because I think the poll gets shut down if the co-host operates them.
Okay. Ma'am,
is a poll.
Sujata, ma'am, you are logged in another device. Polling session is inactive. I think you can launch.
Or if you're able to see the poll.
Yeah, that's the audience, right? So you go ahead.
Yeah. Thank you, Lavna. A small non-technical feedback from my end as an observer. I was just hoping at least one of you, one of the colleges, one of the teams would do a good introduction before you jumped on to giving the solution. So a good presentation skill would mean, would also have a good introduction. So you should probably have a small intro for yourself, for the team who's presenting, people who worked along with you to work on this, arriving at the solution. Take a minute to do that and then, get into the actual presentation.
You want to end the poll?
Yeah, it's actually still people are responding. So okay, I'm ending it now. Okay.
Thank you. So Dr. MGR was the audience favorite.
Yeah, I think MCs can proceed with whatever is the next agenda planned.
Next agenda was vote of thanks, I think.
Now I request PALS champions to proceed with the vote of thanks and final concluding speech.
Before going to that vote of thanks, I will put the feedback in the chat box. Please submit your feedback. So feedback is important for us. Now over to CNC. CNC?
Hi, can you hear me all? Can you all hear me?
Yes.
Yeah, thank you. Okay. Actually, it is very nice, interesting engineering session today. Thanks to Jain Sathe for really coming out with industrial problem. Without a problem, we wouldn't have been able to have this meeting. Thank you very much, Jain, for thinking of this problem and sharing it with the student community. As Professor Cyril Raj, rightly observed, Bloom's taxonomy, where you got levels of learning outcomes starting from understanding all the way to create. He nicely connected this event to Bloom's taxonomy. Thanks, Professor, for joining and giving that opening comment. It really set the stage that students start understanding and they analyze the theory, they analyze map the theory to problem, and then start creating solution. And I think this is a good way of taking the learning framework to the engineering solution that the students really attempted today. And Professor Dr. Suresh from Sona College, called out the engineering skilled engineer is what they should aspire for. Thank you for your opening remark. And Arun Dev nicely, organized this whole program, right from beginning concept all the way to getting the first session going on. Thank you for that. And thanks to Dr. MGR College and I think the two colleges who are hosting are Dr. MGR College and Sona College for hosting the event today. Excuse me. Thank you very much for that. And I must thank Ram and other evaluators who are here today to evaluate student presentations, and of course PMO for doing all the conferencing arrangement and getting all these things going. I think you've been on top of the communication to get this going and reaching this, and we have got 4 more days to go. Thanks, Sujata, for chipping in with your comment as well to students about the presentation. Thanks a lot.
And the teams for their participation and their presentations today.
Right. Sorry, Arun. I think that's my fault. I think sincere thanks to all the students, who looked through the problem and presented the solution. I know this is a learning experience. You will, learn more and more as you go along looking at different industry problems, and sincerely aspire, present you more problems for you to work on. So, you reach the kind of solution that Jayant was sharing with you all. This is a journey, and the end point is what probably Jayant was giving us a real solution for this problem. Thanks, Arun, I think, for jumping in. I shouldn't forget the students ever.
Mr. Arun Dev, Sujata, on obligation has put it in the chat box. The student team from Turbulent.
It's not this audience. Sorry, let me clarify. The audience.
Yes.
Audience poll is not the decision on the technical stuff that you guys have worked a lot to present. Okay, it was more to get an audience viewpoint. As I said at the very beginning, this is an experiment even from PALS as to how to get people involved. And one of the ways how we could look at the audience was to try and get their viewpoint as well. I think midway through, even Sujata had suggested how we could probably get an audience viewpoint also, rather than just have this poll. So don't get too carried away with the poll results. That should not be the limiting factor for you. So don't be concerned about that too much. We did it more as an experiment to find out how to work it through. Having concluded our session, there's only one appeal I have. We have 4 more sessions for the rest of this week where we have similar problems in systems engineering as well as some more core engineering problems. Now that you have attended one, I would like you to please make an effort to try and attend a few more of these so that you get a better exposure of the cases that we are doing, and provide and also call in your peers and students from other branches as well to participate in this event. Thank you.
Thank you.
Anything else? Thank you, Mr. Jayant Sathe, for explaining